side. All right? The bigger side is all by itself because it's c squared and it's a squared and b squared. So with this one, we have 2 square root of 15, 3 square root of 6, and square root of 6. What's one way I could just figure out which is bigger? Blythe?
You could, like, fast or just...
Fast, whatever.
Oh.
How did you figure out which one's bigger?
I just squared all of them.
So one way is to square all of them, and whichever one's bigger is your bigger side, which is awesome. The other way you could do it is just plug in your calculator, pop out a decimal, and whichever one is bigger is also your biggest. Let's say you made a mistake. We can go back to Light's method, even though I made a mistake. So I heard Sahej said at one point you thought that 3 square root of 6 was the biggest, right?
Yeah.
So let's pretend we go along with that. So if I think 3 square root of 6 is the biggest, I'd accidentally put it on the wrong side. And I'd go something like 3 square root of 6 squared is something compared to 2 square root of 15 squared plus square root of 6. That'd be the right setup if 3 square root of 6 was my bigger side. So then we start doing our multiplication. It would be 3 squared, which would be 9, times 6. Bigger than this would be 4 times 15, plus just plain old 6. Now we see 9 times 6 would be 54. Something times 60 plus 6. Right there we can check to see if I did everything right. Because whichever numbers is the biggest started with the original biggest side. So right now I'd look at the fact that this is 60. That should have been my hypotenuse. It is the bigger number of those 3, so that should have been on the other side. So even if you make a mistake, if you just know that one little trick, you'd be able to correct it and go, okay, that should have been the 60, and this should have been the 54 there. It would turn out that we'd end up with 60 equaling 60, which would be a right triangle. So that, in fact, the second one would be a right triangle. Our first one's pretty easy to locate, which is our biggest side, because it has to be that 8. So we do something like 8 squared is something compared to 4 squared plus 6 squared. We'd have 64, 16, 36. We'd say 64. This side would be 52. Well, 64 is bigger than 64, and we said the hypotenuse was on this side, which means our hypotenuse is too big, and if our hypotenuse is too big, it needs to be obtuse. So that one should have been obtuse. The other one should have been a right triangle. None of them are too cute or really cute. Questions on either one of those two? Know how to do those, guys. Those are supposed to be the quick ones on the test, where I just give you 3 numbers and you quickly check. Okay, then questions on the homework. Okay, then we'll go, oh, Twinkle, sorry. 15? Guys? Shh. 15 asks us to decide what x would be in order for the triangle to be acute. In order for the triangle to be acute, the hypotenuse needs to be smaller than adding the other sides. And it does say your longer side is 20. So the original setup of this problem would be something like 20 squared has to be less than x squared plus x plus 4 squared. Because they said one leg is x, one leg is x plus 4. In order for it to be acute, your hypotenuse squared has to be less than, makes it too small, than your 2 sides added squared. Now what you would do is you'd slowly work down, and we're not going to spend a whole bunch of time on this, but you'd slowly reduce this to get 0 on one side, and we'd end up with 0 is less than 2x squared plus 8x minus 384. So that'd be if I square everything and simplify everything, we reduce down to that, which I would go one step further and say, well, 0 is less than 2 times x squared plus 4x minus 192. Well, since we have that x squared plus 4x minus 192, what you need to do is you need to factor it. You need to factor it into a binomial times a binomial. The one method I do to factor it, so we're just going to talk about this part. Let's factor it right over here. So I have x squared plus 4x minus 192. When I factor, I do the a times c Beyonce column. Well, my a times c is whatever number's in front of a, or in front of my x squared is my a term. This is my c term. Well, we have a 1 out front here. 1 times a negative 192 is negative 192, and b is 4. Now I'm looking for two numbers that multiply together to give me negative 192, but when I add them together, they give me a positive 4. And you can just go on your calculator and just do 192 divided by 2, 192 divided by 4. But eventually you're going to end up with 12 and negative 16. Actually, I should flip that and reverse it. It should be negative 12 and positive 16. And negative 12 plus 16 does equal 4. If you check in your calculator, a negative 12 times 16 does equal a negative 192. Now what we do with those negative 12s and negative 16 is we're going to split apart this 4x into negative 12x and a positive 16x. And then everything else is going to fall down with it. So we still have the x squared. We still have the negative 192. Now we're going to separate into two binomials. So the first one is x squared minus 12x. I could pull an x out of both of those, so I'll have x times, I should leave it as purple because that's what I was doing before. We will have x times x minus 12. And for my second binomial, we have, what color can I do? Green. We have this 16x and this 192. Well, it turns out you can pull 16 out of both of those. And you are going to be left with x minus 12 in there. That way we can write this as x plus 16, x minus 12 is going to be our factored form. And so we are sitting with, right now, 0 is less than this. So either to make this true, we have x equaling a positive 12 or x equaling a negative 16. I should probably get rid of that less than sign for just right now. If I had an equal to sign here. If this was equal to, we'd have x equals a negative 16, x equals a positive 12. But we can't use the negative, so we're looking at, if I plug a 12 in for this, I would end up equaling 0. But I want this to be bigger than 0. So we're going to pick any value where x is bigger than 12. We'll make that true. So it all had to do with a bunch of factoring. All right, I went through that really quick. Do you have any specific questions on what I did? You sure? Okay, because I know I kind of ran through as quickly as possible. If you need more help than that, just come see me. We can go through them individually. All right, then let's go ahead and start today's lesson. Today's lessons, we're going to talk about special right triangles. Special right triangles are ones where we will no longer have to use a squared plus b squared equals c squared. You still can if you have enough information, but you're not required to. These are supposed to be ones that you can quickly solve without using the Pythagorean theorem. And that is because these two special triangles have a special relationship between their legs and their hypotenuse. The two triangles we're going to talk about today are the 45, 45, 90 and a 30, 60, and 90. You need to know these when you see them. So you need to recognize the 45, 45, 90, and you need to be able to recognize the 30, 60, 90. The first one we're going to talk about is a 45, 45, 90 triangle. In a 45, 45, 90 triangle, the hypotenuse is always going to be true. This is always going to be true. The hypotenuse is square root of 2 times longer than the leg. And you might be like Mr. Papian, that triangle has 2 legs. It has 2 legs and a hypotenuse. But the cool thing about a 45, 45, 90 degree triangle is it is also an isosceles triangle. It is an isosceles triangle. So each leg is the same size. So if we look right here on the left-hand side, we have a 45, 45. We have 2 sides that are congruent. Both of those sides are called a leg. And then we have a hypotenuse. Now, when we need to solve a 45, 45, 90 degree triangle, I think the easiest way to do it is write it just how I'm writing it and solve it the same way I do. Some of you will have other methods. Make sure they work and you understand them, because if you ask questions, I'm going to go back to this method. I am going to pick a variable to stand for my legs. I'm going to pick S. As soon as I label one of my legs as being an S, I have to label the other one as S as well. In other words, if this one's 2, the other one's 2. This one's 4, the other one's 4. Then I'm going to label the hypotenuse. Well, the hypotenuse is supposed to be square root of 2 times longer than the leg. So I'm going to label this as S square root of 2. So if I know one of my legs is 3, the other leg is 3, and the hypotenuse is 3 square root of 2. So I just need one of these. I either need one leg or one side, and I actually know all of the other information without using a squared plus b squared equals c squared. So let's see how that looks like as an example. Example 1, I have leg BC equaling 5. Like I said, I think the easiest way to keep this organized is to actually just label like I did the other one. I label this S. I'm going to label this leg as S. And I'm going to label the hypotenuse as S square root of 2. Then I'll look at which side is actually has a number on it. Well, that is BC. Well, BC is also our S. So that means S equals 5. It also means that AB equals 5. And it means that AC equals S square root of 2. S equals 5, so it's going to be 5 square root of 2. Yes? Nope. We just need those 3 lengths. And if you have a different way of doing it, then you can do it a different way. So some people don't label them like this. Some people can just kind of picture in their head what they need to do. And it's not so bad with 45, 45, but it's a little harder with 30, 60, 90. So that's why we're using this method. All right, the next one says find the lengths of the missing sides. Once again, if it's a 45, 45, I don't even really look at that 4. I kind of, in my head, that 4 disappears. And all I'm going to do is label each side like I did before. Each of the legs I'm going to call S. And the hypotenuse I'm going to call S square root of 2. Now I'm going to bring that 4 back in. Well, see how that S squared of 2 is pointing at that 4? My next step is to actually write S square root of 2 is going to equal 4. S equals these 2 sides, so I just need to solve for S. What do I need to do to get S by itself? Like? Divide by radical 2. And right now I have S equals 4 over radical 2, which is the full length S. We are pretty much done. We're not going to get the full points. Can someone tell me why I wouldn't give you the full points if you just said BC equals 4 over square root of 2? You sure? Yeah. I don't need to know the answer. I just need to know what I need to do. Will? The denominator can't be a radical. So who knows how to get rid of that radical in the denominator? Yeah, Tyler. Multiply each. I think you mean top and bottom, right? Okay, just making sure. So we're going to multiply the top and bottom by square root of 2, which is going to equal 4 square root of 2 over 2. Well, that means S really just equals 2 square root of 2. Well, if we look at this, length BA equaled length BC, which is now going to equal whatever S is, and that's 2 square root of 2. And we're done. We solved all three. They gave me one side. I named the other two sides. All right, you do the next one. You do the next one. Mostly because it's a little harder. I don't like doing hard problems. Ask questions if you're stuck. That's why we're doing this one. Yeah, Tyler, perfect. Yeah. We do, because see how that's 45? Okay. And this is 90? Oh, if I just do 180 minus, okay. Yep. A right triangle with 145 will always be 45. It's a good question to have, right? Yeah. There is no way to simplify it from there. So now let's kind of number that. We're just going to write s squared of 2 equals 3 square root. Is that 15? Now we need to solve. All right, if you're not done, that is okay. Let's just pay attention just for sake of time so you can have some time to work. I see it's a 45-90, which means this one has to be 45 degrees. It has to be, right? Because it has to add up to 180. So it's a 45-45-90. As soon as I see it's a 45-45-90 in my head, that 3 squared of 15 is kind of disappearing, and I'm just thinking, I'm going to label this S. This side would also be S. And this hypotenuse, whatever it is, would be S square root of 2. Now I just look at which one's actually numbered. Well, that one says it's 3 square root of 15. That's the hypotenuse. So I'm just going to say S square root of 2 is going to equal that 3 square root of 15. To solve for S, I'm going to divide both sides by square root of 2. And we'll have S equals 3 square root of 15 divided by square root of 2. But I do need to multiply the top and bottom by square root of 2 to simplify. Now just a little side note. A lot of times I'll do this in my head. See that square root of 15 times square root of 2? That's going to be the same thing as square root of 15 times 2. You can put it all under one radical bar. So that's how I end up with S equaling 3 square root of 30 divided by 2. Now I can say that CB is actually equal to BA, and they all equal that 3 square root of 30 divided by 2. And you're done. You okay with that one? All right. Our next one's going to be a 30, 60, 90 triangle. Note, a 30, 60, 90 triangle is not isosceles. So we have 3 different sizes. We have a short leg, a long leg, and a hypotenuse. So we need to talk about all 3 of those. So the hypotenuse is going to be 2 times as long as the short leg. The longer leg is going to be square root of 3 times as long as the short leg. How do I know which one's the short leg? I know which one's the hypotenuse because it's across from 90 degrees. How do I know which one is the short leg? We have a long leg and a short leg. Stephanie?
The one across from 30?
The one across from 30. So that's what I'm going to put here. The shorter leg is always opposite the 30-degree angle. All right, so in plain English, on the left-hand triangle, the one across from 30 degrees is our short leg. The one across from 60 degrees is the longer leg. And then we also have a hypotenuse, as always. So just like a 45, 45, 90, I have a specific way I label this. Remember, these are just my variables. I pick S. You can pick whatever. You can do an X. You can do smiley face. You can do an, I guess S works for hedge, right? So what I'm going to do is I'm going to label the short leg first. I'm going to call that S. My short leg is S. My hypotenuse is twice as long as my short side, so that's going to be 2 times S, or 2S. The one across from 60 is square root of 3 times as long, so it's going to be S square root of 3. You could think of it as being square root of 3 times S, but we always put the variable up front so it doesn't accidentally fall underneath that square root symbol when you're writing it. Realistically, I kind of remember this as just being 1, 2, 3, and the square root goes on the 3. These are things you have to memorize, okay, guys? There's no theorem sheets on this one. You do have to know how all those sides relate to each other. So it's S, 2S, S square root of 3. Well, then every other problem is the exact same thing as with the 45, 45, except we're going to change how we label stuff. So on this one, I find my 30-degree angle. That's that L. So MN is going to be my S. LM is my longer side, so that's our S square root of 3. LN is my hypotenuse, which is 2S. Now I see that 2S is pointing at that 14. So the start of my equation is going to be 2S equals 14, which means that S just equals 7. Well, MN equals S, so MN just equals 7. LM equals S square root of 3. Well, S is 7, so that's going to equal 7 square root of 3. And we're done with that one. Next one, we're going to do the exact same thing. We're going to locate our 30-degree angle. Our 30-degree angle on our next one is L again. So I'm going to label the side opposite LS. I'm going to label my hypotenuse 2S. I'm going to label that long leg, the one across from 60 degrees, that S square root of 3. Well, the good thing about this one, our S is done. That S is pointing to 2 square root of 5, so just S equals 2 square root of 5. NL equals 2S, so that's just going to be 2 times that 2 square root of 5, which is just going to equal 4 square root of 5. The last thing I need to solve is for ML. ML is just S square root of 3. Our S in this case is 2 square root of 5. So we'll have 2 square root of 5 times square root of 3, which is actually just going to be 2 square root of 15. Once again, you are doing that last one. You are doing that last one. Show me you know how to do it. Sag.
Find S.
Find S. Where would that go?
On the bottom.
On the bottom one. I'm going to call that one S. What would I call the hypotenuse?
S. Oh, well, 8. So S radical 3.
S.
No, wait.
Oh, sorry.
Where
Oh,
the
I
8
said
is.
hypotenuse. What would I label the hypotenuse?
Oh, 2S.
2S. There you go. I think you meant the S square root of 3 would go there, right? Okay, what do I do next? Who can tell me what to do next? Lythe.
S square root of 3 equals 8.
Yep, S square root of 3 equals 8. What's my next step? Yeah, Tyler.
Divide both sides by square root of 3.
Divide both sides by square root of 3. So I have S equals 8 square root of 3. What's my next step? Yeah, Will.
So I was just thinking.
Yeah.
I was thinking stuff now. So you multiply both sides by square root of 3.
Not both sides.
I meant not both sides. The numerator and the denominator.
Yeah, much better, much better phrasing. So we're going to multiply the bottom and top, or the numerator and the denominator, by square root of 3. And that's going to end up equaling 8 square root of 3 divided by 3. There's no way to simplify that. So that means Mn, which just equals S, is going to be 8 square root of 3 divided by 3. Can someone tell me what Ln would equal then? Yeah.
16 square root of 3.
It would be 16 square root of 3 over 3 because it was 2 times S. So it'd be 2 times 8 square root of 3 over 3, which would equal 16 square root of 3 over 3. The hardest part should be just the simplifying. And that isn't worth the most points in the problem. The most points in the problem come from, did you just set this up correctly, and did you kind of know, did you get to this 8 over square root of 3? All right, if you mess something up there, it's like half point to a full point, depending on how bad you messed it up, right? If you decided to get rid of the square root of 3 by just crossing it out, then you're not going to get any points for that. All right, questions on anything we covered today? All right, the rest of the time is for you to work on the homework. I do want to point out that if you turn to the very last page of your homework, it does have all your answers. That being said, keep paying attention. Ethan. Keep paying attention. The answers are all right there, but I also did post the solution guide online. So if you're stuck and you want to see my work, it is online. So if you're just like, I have no idea where they got this number from at all, you can then go online and check to see how I did it by hand. All right, so it's all online as well. But if you got all these right, then you don't have to go online because they're all right there. All right, yeah, Lythe.